Hello there, this is Mr. Greve, and this is a short 3-minute video on how to draw Lewis structures for polyatomic molecules. I'm going to go through two quick examples as shown on the screen here. The first is CCl4 and the other is H2O or water. Before we begin, I've highlighted the 3 steps that you need to take in order to draw Lewis structures for polyatomic molecules. The first one is to count the total number of valence electrons in your molecule. The second is to make octets, or 8 electrons, unless it's hydrogen, which only needs 2. Make octets around each atom. And then finally, the third step is to check and make sure that the total number of valence electrons in your molecule matches what you found in part 1. Okay, so let's start with CCl4. Carbon has 4 valence electrons, plus each chlorine atom has 7 because it lives on the 7th group or family or column of the periodic table, and there are 4 of them, so it's 7 plus 7 plus 7 plus another 7. So 7 times 4 is 28, plus 4 makes a total of 32 valence electrons in this molecule. Okay. Now, carbon has 4. So carbon is going to make the most bonds in this molecule, and you put the atom that is going to make the most bonds in the center. So in this case, we're going to put carbon in the center with its 4 valence electrons. And then chlorine, with its 7 valence electrons, is going to make a single bond right here with each one of those lone electrons around carbon. So a bond, and we cannot forget about our lone electron pairs. So I've proposed a Lewis structure. I need to make sure that each atom in my Lewis structure has 8 electrons around it to fulfill the octet rule. And then I need to count all the electrons to make sure that there are indeed 32. Okay, so let's count electrons around each atom. This chlorine atom has 2 in the bond, 2 lone pairs, another 2 lone pairs, and then another 2 lone pairs. So this chlorine atom has 8, as does this chlorine atom, 2, 4, 6, 8. So this chlorine atom is good. This chlorine atom is good. This chlorine atom has 2, 4, 6, 8. So that chlorine atom has an octet. This chlorine atom has 2, 4, 6, 8. And so that as well. The chlorine atoms are energetically stable with their octets, and the carbon has 2, 4, 6, 8 with those 4 single bonds. So carbon has an octet as well. So all the atoms are good in terms of the octet. Now we need to make sure we haven't added more electrons than we should. There should be 32. Each chlorine atom has 2, 4, 6, 8. Okay, and there's 4 chlorine atoms, so 8 times 4 is 32. So I indeed have 32 electrons. So that is the correct Lewis structure for chlorine. Now let's name this. I've got 1 carbon atom and 4 chlorine atoms. So the name of this molecule is carbon tetra meaning 4, chloride. Carbon tetrachloride. You would get this tetra from the list of prefixes that are in the content library in the lecture notes for diatomic molecules. I've placed it there. And I'll place it there for polyatomic molecules as well. Let's move on to do H2O, also known as water. Okay, so hydrogen has 1 valence electron, but there are 2 of them. And then oxygen has 6 valence electrons. So 1 plus 1 plus 6 equals a total of 8 valence electrons. Oxygen is going to make more bonds than hydrogen, so we put oxygen in the center with its 1, 2, 3, 4, 5, 6 valence electrons, and then the hydrogens with their single valence electron. There, we form a single bond between the hydrogen and the oxygen. And so I have a Lewis structure. Let's make sure it's the correct Lewis structure by counting octets. I've got 2, 4, 6, 8 around oxygen. So oxygen is good. Hydrogen has 2. So hydrogen has an octet. And this hydrogen also has an octet because hydrogen is the exception to the octet rule. It only needs 2. It's the only atom that only needs 2. All the other atoms need 8. Okay, so I do have the correct Lewis structure with drawing it like this just for you. That is the Lewis structure for H2O or water. The name of this molecule, the way we would name a covalent molecule like this, we would say that this is di for 2, dihydrogen, because there's 2 hydrogen atoms. Dihydrogen monoxide. Okay. Dihydrogen monoxide. The common name, of course, we know is water. Hopefully this helps. And hopefully you can apply this to your homework, doing the Lewis structures for everything in the table there.